Okay, so here we are with one-to-one functions and their inverses, lecture 2.8. So we have the new type of test. It's called the horizontal line test. Not to be confused with the vertical line test. So the horizontal line test is to check if a function is one-to-one. So the vertical line test was to see if something was a function. Now we have the horizontal line test to see if a function is one-to-one. And it is one-to-one if when you pass a horizontal line through the graph, it touches no more than once. So let's take a look at A. If I pass a horizontal line through this graph, does it touch more than once? Well, yes, it touches 1, 2, 3, 4 times. So this is not one-to-one. How about this line? Well, I can actually check multiple places. That's supposed to be a horizontal line. Did not come out quite that way. But it only passes once. So this is one-to-one. So here's a question. Is a horizontal line one-to-one? No. If I crossed a horizontal line through a horizontal line, it would hit infinitely many times. So a horizontal line is not one-to-one. Alright, so let's take a look at the definition of a one-to-one function. So a function with a domain A is called one-to-one if no two elements of A have the same image. That is, if x1 does not equal x2, then f of x1 does not equal f of x2. Okay? Or another way of looking at it, if you have two functions, two y values that are equal, then the x values that created those y values should be the same. So let's determine whether the function is one-to-one. So here's the test we're going to do. We're going to start with this end and see if we end up with x of 1 equal to x of 2. Then we know it is one-to-one. So we're going to do f of x1 and see if that's equal x of x2. We're going to solve this and see if we end up with x1 equals to x2. So this is the absolute value function. So we're going to go ahead and plug that in. Now this looks kind of weird, but we can simplify two absolute value functions equal to each other by just taking one out of the absolute values and then treating the other one as the positive and negative case. So the x2 minus 2 will be the positive case, and then we'll do the negative case on this side. Okay, let's go ahead and solve. Well, if I add 2 to both sides, that'll cancel. And what do I have here? I have x1 equals x2. I might be really tempted to say that this is one-to-one because it satisfies that requirement there. But I need to check to make sure it works on this side as well. So distributing in the negative, I get x1 minus 2 equals 2 minus x2. Well, if I add 2 to both sides, I end up with x1 equals 4 minus x2. There's no way to actually get x1 equal to x2. I can't find a way to get rid of that 4. So this doesn't actually work. So this function, even though it worked on this half, it didn't work here. So f of x equals the absolute value of x minus 2 is not one-to-one. Let's go ahead and check B. So same thing, we're going to test with the input of x1 to the input of x2 and see if we can end up with x1 equal to x2. So this is going to be 3x1 plus 1 equal to 3x sub 2 plus 1. All right, we can subtract 1 from both sides. And then we have 3 times x sub 1 equals 3 times x sub 2. And if we divide both sides by 3, look what we end up with. We end up with x sub 1 equals x sub 2, which is what I need to prove that it's one-to-one. I started out with the f inputs, or the function inputs, and I ended up with x of 1 equals x of 2. And there we go. So, g of x is 1 to 1. And you know what? I'm going to write this real quick. F of x is not 1 to 1. Okay, moving along. So the definition of an inverse function. Let f be a 1-to-1 function with a domain A and range B. Then its inverse function, f inverse, has the domain of B and a range of A. Notice the domain and range got swapped. And it's defined by, so if you have f inverse of y equal to x, then f of x is equal to y. So we're given these values. If f of 3 equals negative 5, f of 0 equals 7, and f of negative 4 equals 0, find f inverse of negative 5, f inverse of 7, and f inverse of 0. Well, we're going to go ahead and use our given definitions to go ahead and figure this out. So, f inverse of negative 5. Well, according to this, f inverse of a value y will equal x, and we can tag that to when it equals to y. So I'm going to look for, of these functions, which one of these equals negative 5? Well, this one equals negative 5. So since this equals negative 5, my equation, or my definition up here tells me that the x value is the input that I'm looking for. So what's the input for negative 5? The input is 3. So f inverse of negative 5 is going to be 3. Okay, let's try the next one. F inverse of 7. Well, I'm going to look for one of these functions that has the y value of 7, and that would be this one, right here. So what's the x value of this one? 0, which means f inverse of 7 is going to be 0. Last one, f inverse of 0. So, again, we're going to look for where, instead of the x value, we're going to look for where the y is 0. So which one of these has a y of 0? This one right here. So what is the x value for this? The x value is negative 4. So f inverse of 0 is negative 4. So basically notice what happens is the inverses, their x and their y's are swapped. X and y are swapped. Okay, so for inverses. Okay, so notice if I look at these two, they're inverses because their x and y values have been swapped. Just like these, x and y are swapped, and these, x and y are swapped. All right, inverse function property. So let f be a 1-to-1 function with a domain A and a range B. The inverse function, f inverse, satisfies the following cancellation properties. So you put one function inside the other, so f inverse of f of x equals x for every x in A. And this other requirement where you instead input the inverse. So it says, conversely, any function f inverse satisfying these equations is the inverse of f. Okay, so we have to check and make sure that both of these requirements are satisfied to see if something is the inverse. So for example 4, it says verify that fx, 2x minus 1, and g of x of a half x plus a half are inverses. So to do this, I need to check both of these equations. And each time I need to end up with it equaling x, and then I know that they are inverses. So let's do f inverse Let me back up for a second. So to see if they're inverses of each other, I'm going to input one into the other. So first, I will do f of g of x and see if I end up with x. that x. And then I'll do the opposite direction, g of f of x, and see if I end up with x. And if I do end up with x both times after doing simplifying, then I know they're inverses. Okay, so this is going to equal, well, my input value is this. So wherever I see x, for my f of x, I'm going to input this whole binomial. So that's me 2 times my new input, which is g of x, and then minus 1. Okay, we can distribute the 2 in. When we do that, those 2's cancel, so we're left with x plus 1 minus 1. And that simplifies, and I'm left with x. Well, this one was satisfied. I ended up equaling x, so that's pretty good. Let's try this one. So that's going to be 1 over 2 times, and my input is going to be f of x, which will be 2x minus 1. And then plus a half. Okay, let's go ahead and simplify this. So distributing in the half, I have x minus a half plus a half. And what do you know? The halves will cancel, and I'll be left with x. So it worked. Both of the equations were satisfied. Therefore, f of x and g of x are inverses. So f of x and g of x are inverses. Okay, just one more page to go. Awesome. All right, so how to find the inverse of a one-to-one function. This is fun. Okay, so what you're going to do is you're going to write y equals f of x and then solve this equation for x if possible. Then, once you've done this, interchange x and y, and the resulting equation is y equals f inverse of x. Okay, so we're going to go ahead and try and solve for this. So, I'm going to write y equals f of x. So y equals 2x minus 1. And let's solve for x. So solving for x, add 1 to both sides. So we have y plus 1 equals 2x. Let's divide x, or 2, from both sides. So y plus 1 divided by 2 equals x. All right, and then, remember what we said about inverses is their x and y's are switched. So we're going to go ahead and do that, switching the x and y. So it's going to be x plus 1 over 2 equals y. And so the resulting equation is going to be our f inverse. So I can rewrite this as f inverse of x equals x plus 1 divided by 2. All right, let's try that with this side. Find the inverse. Okay, so plan. Write it y equals, and then we're going to solve for x. All right, I'm going to get rid of the fractions first. So let's cross multiply. So that's going to be y times x plus 3 equals 2x minus 1. The bug is back. No. Okay. Let's distribute in that y. So I have xy plus 3y equals 2x minus 1. Let's get the x's on one side. So I'll subtract the 2x from both sides. So xy minus 2x plus 3y equals negative 1. My goal still is to get the x on it by itself, so I'll minus the 3y from both sides. And I have xy minus 2x equals negative 3y minus 1. So to get x to appear once, I will factor out the x, and I'm left with y minus 2 equals negative 3y minus 1. Let's divide both sides by y minus 2. And I have x equals negative 3y minus 1 over y minus 2. Okay, once I've done that, I have solved for x. I will go ahead and swap the x and y's. So y equals negative 3x minus 1 all over x minus 2. And that there is my inverse function. To check if it's the inverse, we can do what we did in the last example and input them into each other. Okay, the last piece. Graphing the inverse of a function. Okay, so our plan is to exchange the x and y values, and the graph will reflect about the line y equals x. Axis of symmetry. So the line y equals x, right there. Axis of symmetry. Okay, so first things first, I like to go ahead and draw in my axis of symmetry. Okay, so remember our plan is we're trying to find the inverse of this red graph. So my axis of symmetry is going to go through these points where it's 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. Okay, so I'm going to go ahead, draw a line through those points. And that right there is the axis of symmetry, y equals x. And then what we're going to do to plot these, we're just going to switch the x and the y's. So right now I'm just going ahead and finding the points I can actually identify to make it easier to swap. Okay, these ones look like the points I can identify. Alright, so what is this point? That is 1, 2, 3, 3, 1. This point is 1, 0. And this point here is negative 1, 3. Negative 3. And the last point, 1, 2, 3, 4, negative 4, negative 4. Okay, so these are all the points. And what I'm going to do for my inverse, let's just call this function f. So my inverse function is going to be the swap of all these values. So what's the swap of 3, 1? Well, that's going to be 1, 3. How about the swap of 1, 0? 0, 1. The swap of that, negative 3, negative 1. And the swap of this, negative 4, negative 4. So I'm going to go ahead and plot those points to find my inverse. So 1, 3. 1, 1, 2, 3. 0, 1, 0, 1. Negative 3, negative 1. Negative 3, negative 1. And lastly, negative 4, negative 4. Okay, so these guys should end up mirroring each other. Notice how this one mirrored each other on the graph? That's exactly what we're looking for. These guys should end up mirroring each other. Okay, so through there, and lastly, down through there. And there we go. Is my f inverse. So I found the points that I could find, and then I took the flop of them, and that was my inverse. Okay. And that is it for 2.8. Here's your written homework due by the end of the week. Please email me if you have any questions.